May 28, 1940, 9:40 hours. Reich Air Ministry, Berlin. Reichsmarschall Hermann Göring lowers an intelligence report onto his desk, the paper still warm from delivery, while outside German armored columns advance through France at speeds exceeding 25 kilometers per day. The document outlines President Franklin Roosevelt's request to Congress. The United States intends to produce 50,000 aircraft annually. Göring reads the number again, then dismisses it with a quiet laugh. In 1939, America built just 3,611 military aircraft. Its Army Air Corps fields barely 1,700 operational planes, many already obsolete. To him, the figure is not a plan but propaganda. He remarks that automobile factories cannot simply transform into aircraft production lines, that warplanes require precision craftsmanship, not mass assembly. The report is set aside, its implications ignored. Within 4 years, however, the same nation will produce 96,270 aircraft in a single year, including 16,048 heavy bombers and 35,743 fighters, numbers that will turn the skies over Europe into a permanent front line. At this moment, Göring does not understand that the war has already shifted from the battlefield to the factory floor, and that Germany is entering a conflict it cannot mathematically win. At that moment, German leadership was confident in a single, deeply rooted assumption: modern war production required centralized control, long-term preparation, and highly specialized labor, conditions the United States did not possess in 1940. This belief was grounded in experience. The Reich had spent years building a command economy, directing resources through ministries, training engineers, and refining aircraft design through companies like Messerschmitt and Junkers. By 1940, German industry was producing roughly 10,000 aircraft annually, supported by a disciplined workforce and access to continental resources. Aircraft manufacturing was treated as a technical craft involving tens of thousands of precision components, not something that could be scaled through civilian industry. Reports that American automobile companies intended to enter aircraft production were interpreted as technical naivety. Göring openly stated that assembly lines designed for cars could not produce combat aircraft. Intelligence reinforced this view by emphasizing America's lack of military readiness and its fragmented industrial structure. A 14-fold increase in production, from 3,611 aircraft to 50,000 annually, appeared to violate every principle of industrial planning. The conclusion seemed logical: the United States was bluffing, and even if it attempted such expansion, the result would be inefficiency, poor quality, and eventual collapse. On paper, Germany's industrial system appeared superior in every measurable category. The Reich controlled a centralized war economy supported by occupied European industry and enforced through strict command structures. Production was organized through specialized manufacturers, each responsible for specific aircraft types, ensuring technical consistency and engineering focus. The system included established supply chains for aluminum and steel, access to forced labor, and a workforce trained over years of militarization. By 1940, Germany's aircraft output had already reached levels that placed it among the leading producers in the world. The doctrine emphasized quality over quantity, relying on advanced designs like the Bf-109 to offset numerical disadvantages. Early campaigns in Poland and France seemed to validate this model, as the Luftwaffe achieved air superiority against opponents with larger but less coordinated forces. Every calculation pointed toward sustained dominance: superior engineering, disciplined production, and centralized control would secure victory. In contrast, the United States appeared disorganized, with civilian industries untested in military production and a workforce lacking technical specialization. German planners saw no scenario in which such a system could outperform their own. Yet subtle inconsistencies began to emerge. Reports from German attaches in Washington described rapid industrial mobilization that exceeded expectations, including factories retooling at unprecedented speed and production schedules expanding beyond peacetime limits. Observations indicated that companies like Ford and General Motors were not only entering aircraft production but restructuring entire facilities to accommodate it. Additional intelligence noted the introduction of multiple work shifts, day, night, and extended cycles, effectively multiplying output without proportional increases in infrastructure. Labor data revealed a rapidly expanding workforce, including women entering industrial roles in significant numbers. By 1943, women would represent more than 65% of aircraft workers, totaling over 310,000 individuals. German analysts interpreted this as a sign of desperation, assuming that untrained labor would reduce quality and efficiency. Reports of factories operating continuously were dismissed as exaggerations, while the scale of American industrial coordination was underestimated. Each signal contradicted existing assumptions, yet none were taken seriously enough to alter strategic thinking. Then the scale became undeniable. By December 1941, American factories were already producing 2,000 military aircraft per month, a 20-fold increase in just 2 years. This growth did not stabilize, it accelerated. By 1943, production expanded further, and by 1944, the United States reached 96,270 aircraft in a single year, surpassing Germany's total wartime output of approximately 94,677 aircraft. The disparity extended beyond numbers. A single facility, Ford's Willow Run plant, covering 3.5 million square feet, operated a 1-mile assembly line producing one B-24 bomber every 63 minutes. At peak efficiency, monthly output reached 428 bombers, exceeding the production capacity of entire German industrial sectors. American factories implemented innovations such as modular assembly, hydraulic riveting, and prefabricated wiring systems, allowing continuous adaptation to design changes, 578 modifications in 1943 alone, without halting production. German intelligence struggled to interpret these figures because they violated the fundamental assumption that complexity limited scale. What they were witnessing was not incremental improvement but a transformation of industrial logic itself, where quantity, adaptability, and continuous production combined to create a level of output that no centralized system could match. What followed destroyed the last illusions of control. The first combat reports from 1942 and early 1943 revealed a pattern that could no longer be dismissed as statistical anomaly. German fighter units in North Africa began encountering increasing numbers of American aircraft, not just replacements but entirely new formations arriving continuously. In December 1942, Major Johannes Steinhoff of Jägerschwader 77 noted that American pilots were no longer inexperienced and, more critically, their numbers were growing daily. Losses that would have crippled any European air force were being replaced within weeks. By January 27, 1943, the first American bombing raid struck Germany itself, 64 heavy bombers attacking Wilhelmshaven. By October, during the Schweinfurt missions, the United States lost 60 B-17 bombers in a single operation. For Germany, such losses would have required months to recover. The Americans replaced them within 2 weeks. The mathematics had shifted irreversibly. As the air war intensified, the scale of production translated directly into operational pressure. During Big Week from February 20 to 25, 1944, the U.S. 8th and 15th Air Forces launched over 3,500 bomber sorties against German aircraft production facilities. The Luftwaffe lost between 262 and 355 fighters in those few days, but the critical loss was not machines, it was pilots. Approximately 100 experienced airmen, many with years of combat experience, were killed or captured. German training programs, already constrained by fuel shortages, could not replace them at the required pace. General Adolf Galland reported that Germany was losing 1,200 fighters per month while producing only 1,000. The United States, in contrast, was producing 2,500 fighters monthly while losing roughly 400. This imbalance was not temporary, it was systemic. Every engagement reduced German capability while leaving American strength largely intact. The disparity extended beyond aircraft counts into equipment, technology, and supply. Each American heavy bomber carried up to 13.50 caliber machine guns with thousands of rounds of ammunition, powered turrets, advanced bomb sights, and reliable radio systems. German interceptors increasingly flew with reduced ammunition loads due to shortages, sometimes lacking fully functional communication equipment. Boeing's Seattle Plant 2 alone was producing 16 B-17 bombers per day by mid-1944, while Douglas Aircraft expanded from 68 employees in 1936 to 167,000 workers across 9 facilities. North American Aviation produced 500 P-51 Mustangs monthly, aircraft capable of escorting bombers deep into Germany, eliminating the Luftwaffe's previous advantage in range. Supporting industries expanded at comparable rates. General Motors manufactured 57,658 aircraft engines under license, Packard produced 55,523 Rolls-Royce Merlin engines, and aluminum production increased by 600%, ensuring no material shortages. The system was no longer constrained by resources, it was defined by abundance. The turning point was not a single battle but a realization spreading through German command structures. Pilots reported bomber streams stretching from horizon to horizon, formations of 700 or more aircraft protected by hundreds of escort fighters. Major Heinz Bahr described missions where 8 German fighters faced hundreds of bombers, calling the situation hopeless. The Luftwaffe, once a decisive instrument of blitzkrieg, was being reduced to a reactive force, unable to influence the strategic balance. Factories dispersed into 729 underground facilities in an attempt to survive Allied bombing, employing over 60,000 forced laborers, yet productivity declined and defect rates increased. Transportation delays between fragmented sites further reduced output efficiency. The entire system, designed for control and precision, began collapsing under the pressure of scale. Meanwhile, American production demonstrated a different principle entirely: adaptability. When combat revealed vulnerabilities in bomber formations, modifications were introduced within weeks. Boeing added Chin turrets to counter frontal attacks in less than 60 days. Lockheed implemented over 2,100 combat-driven modifications to the P-38 Lightning without halting production. Information flowed directly from combat units to engineers and then to assembly lines, creating a feedback loop that continuously improved performance. German systems, constrained by hierarchy and fragmented production, could not match this speed. Their aircraft entered service as fixed designs, while American machines evolved constantly. By mid-1944, the consequences became visible on a strategic scale. On June 6, during the Normandy landings, Allied air forces deployed 11,590 aircraft against just 319 German sorties, a ratio of 36-1. This was not tactical superiority, it was industrial dominance expressed in operational form. Between January and May 1944, Allied bombing campaigns dropped 145,000 tons of bombs on German targets, exceeding the total German bombing of Britain during the entire war. Transport aircraft delivered entire airborne divisions in a single day, using more planes than Germany's entire transport fleet. The skies over Europe were no longer contested, they were controlled. At this point, German command began to understand the nature of the conflict they were losing. The problem was not tactical failure, nor lack of technological innovation. Jet aircraft like the Me-262, capable of speeds 100 miles per hour faster than Allied fighters, represented genuine breakthroughs. Yet Germany produced only 1,430 of these aircraft, with fewer than 200 operational at any given time. Engine lifespans were limited to 10 hours, and material shortages forced inferior substitutions. Meanwhile, the United States pursued multiple aircraft programs simultaneously, producing thousands of conventional fighters while developing next-generation technology. Innovation without production capacity proved irrelevant. The realization came too late. By 1944, the United States alone produced more military aircraft than the rest of the world combined, Allied and Axis. German officers reviewing the numbers understood the implication: this was no longer a contest of armies but of industrial systems. One system relied on control, specialization, and limited resources. The other operated on scale, flexibility, and effectively unlimited production. The outcome was no longer uncertain. It had been determined years earlier, in factories rather than on battlefields. The collapse did not occur in a single moment, but in a series of irreversible conclusions drawn by those who witnessed the numbers firsthand. By late 1944, even the highest levels of the German leadership could no longer ignore the scale of disparity. Joseph Goebbels recorded in his diary that Göring's promises of Luftwaffe superiority had become criminal delusions, an admission that propaganda could no longer conceal material reality. Field Marshal Erwin Rommel, observing Allied preparations before the Normandy invasion, warned that once the Americans landed, they would arrive with such overwhelming material superiority that no defensive position could hold. His estimate was brutally simple: the Allies could lose 10 tanks for every German one destroyed and still advance. This was no longer a question of tactics or leadership, it was arithmetic. By this stage, the production gap had expanded beyond aircraft into every category of war material. American factories were not only producing planes but engines, aluminum, fuel, and replacement parts at rates that exceeded German capacity by multiples. In 1944 alone, the United States produced 812,615 aircraft engines compared to Germany's 241,675 over the entire war. Aluminum output increased sixfold, while chemical industries expanded magnesium production from 6 million to 333 million units annually. These figures translated directly into operational endurance. American forces could sustain continuous bombing campaigns, maintain global supply lines across both the Atlantic and Pacific, and replace losses faster than they occurred. German forces, by contrast, faced constant shortages of fuel, spare parts, trained personnel, and time. The internal structure of German production further accelerated collapse. In response to Allied bombing, the Reich dispersed manufacturing into 729 underground facilities, relying heavily on forced labor. Approximately 60,000 prisoners were employed in these complexes, with 20,000 dying under extreme conditions. Instead of increasing output, dispersion reduced efficiency. Transportation between facilities introduced delays, sabotage became widespread, and quality control deteriorated. Engines failed prematurely, aircraft components were defective, and entire production lines became unreliable. A system designed for precision and control had fragmented under pressure, losing both. Meanwhile, American factories increased efficiency despite operating at larger scales, introducing statistical quality control and modular assembly techniques that reduced defects while accelerating output. The psychological impact of this disparity was profound. German pilots entering combat in 1944 no longer expected to achieve air superiority, they expected to survive against overwhelming numbers. Bomber formations stretched across entire horizons, escorted by fighters that could reach any target within Germany. Losses inflicted on Allied forces had little strategic impact, as replacements arrived within days. For German units, every loss was permanent. This imbalance eroded morale and operational effectiveness simultaneously. Reports from frontline units increasingly described not battles but attrition without recovery, a continuous reduction of capability against an enemy that only grew stronger. The final realization emerged from direct comparison. During interrogations after his capture in 1945, Hermann Göring admitted that while he had understood the theoretical potential of American industry, the execution exceeded anything he had imagined. He expressed particular astonishment at a single facility, Willow Run, producing more bombers than the entire German force at its peak. When presented with production statistics showing American monthly output surpassing Germany's annual totals, he reportedly fell silent. The mathematical reality of defeat could not be argued, only observed. The transformation from 3,611 aircraft in 1939 to nearly 300,000 by war's end represented not growth but industrial dominance on a scale that rendered opposition futile. By May 8, 1945, the outcome was complete. Germany had produced approximately 94,677 aircraft over the entire war, while the United States alone produced 295,959. The Luftwaffe had been reduced to a fraction of its former strength, its pilots depleted, its production system broken. The Allied bombing campaign had destroyed critical infrastructure, reducing German tank production by 35%, aircraft production by 31%, and truck output by 42%. Cities lay in ruins, supply lines collapsed, and remaining forces lacked the material to continue effective resistance. The defeat was not sudden, it was cumulative, the result of years of imbalance that no battlefield success could reverse. This story revealed a fundamental truth about modern warfare. Victory was not determined solely by strategy, bravery, or technological innovation. It was decided by production capacity, logistics, and the ability to sustain operations at scale. Germany possessed advanced weapons, experienced commanders, and early tactical superiority, yet these advantages proved insufficient against an opponent capable of producing and replacing resources on an industrial level. The United States did not simply outfight Germany, it outproduced it, outsupplied it, and ultimately overwhelmed it through sheer material superiority. The lesson was unmistakable. Wars in the industrial age are won not only by those who fight better, but by those who build more, faster, and continuously. Germany entered the conflict believing quality could compensate for quantity, that centralized control could outperform decentralized industry. It discovered, too late, that scale itself was a weapon, one that, once unleashed, could not be countered by strategy alone. What remained after the collapse was not just defeat, but comprehension, slow, reluctant, and unavoidable. German officers who survived the war began to articulate what had truly happened, stripping away ideology and focusing on measurable reality. General Heinrich Eberbach later summarized the imbalance with clinical precision. Allied superiority reached ratios of 20-1 in artillery, 10-1 in armored vehicles, and absolute dominance in the air. These were not temporary advantages but structural conditions that defined every engagement. Even when German units achieved tactical success, destroying Allied tanks or repelling localized attacks, the results had no lasting effect. Losses were replaced within days, sometimes within hours, while German formations diminished permanently. The battlefield had become an extension of industrial capacity, where production rates dictated operational possibilities. This understanding extended beyond numbers into the nature of the systems themselves. American industry operated as a continuous cycle, raw materials converted into machines, machines deployed into combat, losses absorbed and replaced without interruption. Supply chains stretched across oceans, delivering fuel, ammunition, and spare parts over distances exceeding 5,000 miles, yet maintaining consistent flow. German logistics, by comparison, struggled to sustain operations even 500 miles from industrial centers. Fuel shortages grounded aircraft, limited training hours for pilots, and restricted armored movements. By late 1944, many Luftwaffe pilots entered combat with fewer than 60 hours of flight training, compared to over 250 hours earlier in the war. The degradation was not sudden but cumulative, a steady erosion caused by insufficient production and supply. The contrast became most visible in the final year of the war. American factories produced aircraft at such scale that new models could be introduced without interrupting existing output. The B-29 bomber, incorporating pressurization, advanced navigation systems, and long-range capability, entered production while earlier models continued to roll off assembly lines in massive numbers. At the same time, fighter production remained constant, ensuring air superiority across multiple theaters. Germany, facing resource shortages and fragmented production, could not sustain even its existing programs. Advanced projects like the Me-262 jet fighter, despite superior speed and performance, were produced in limited numbers, 1,430 units in total, with operational availability often below 200 aircraft due to maintenance and fuel constraints. Innovation existed, but without production depth, it had no strategic impact. Economic consequences reinforced the imbalance. American war production, valued at $45 billion in 1940s currency, equivalent to approximately $800 billion today, not only sustained military operations but transformed the domestic economy. Unemployment, which had defined the Great Depression, disappeared entirely. Industrial output expanded across sectors, with 2 million workers employed in aircraft production alone. Personal income doubled between 1940 and 1945, while war bond programs financed large portions of industrial expansion. Germany, in contrast, devoted up to 40% of its industrial capacity to aircraft production by 1944 yet failed to match even half of American output. Reliance on forced labor reduced efficiency, increased sabotage, and lowered product quality. Productivity per worker declined after 1943, while American productivity increased by approximately 300% over the same period. By the final months of the war, the disparity was no longer analyzed, it was accepted. German prisoners of war reported being more shocked by Allied abundance than by firepower. Observations of American soldiers discarding equipment, using fuel freely, or receiving constant resupply undermined morale more effectively than combat itself. Letters from German soldiers described a war against infinite resources, where every destroyed vehicle was replaced by several more. This perception reflected reality. By 1944, the United States alone accounted for roughly 50% of global manufacturing output, producing aircraft, vehicles, and munitions at rates unmatched in history. The conclusion drawn by both sides converged on a single point. The outcome of the war had been determined not by a single campaign or battle, but by the capacity to sustain and expand production over time. Tactical brilliance, technological innovation, and individual heroism could influence engagements, but they could not overcome systemic imbalance. Germany's early victories had been achieved through speed and coordination, but those advantages required a foundation of supply that could not be maintained against an opponent with vastly superior industrial capacity. In the end, the transformation that began with a dismissed report in May 1940 defined the entire conflict. A nation initially perceived as unprepared and fragmented reorganized itself into an industrial system capable of producing nearly 300,000 aircraft over the course of the war, while simultaneously supporting operations across 2 oceans. This was not merely an increase in output, it was a redefinition of how war could be fought and sustained. The final insight is unavoidable. Modern war is decided long before armies meet in battle. It is determined in factories, supply chains, and production systems that define what is possible on the battlefield. Germany relied on control, specialization, and limited resources. The United States relied on scale, adaptability, and continuous production. The result was not just victory, but overwhelming dominance. The war proved that industrial power is not a supporting element of warfare, it is its foundation. By the time the war ended, the transformation extended far beyond aircraft counts or battlefield outcomes, it reshaped the entire structure of modern industry. The systems developed to sustain mass production did not disappear with victory, they became the foundation of post-war economic dominance. Facilities built for bomber production transitioned into civilian manufacturing, aluminum plants that once supplied aircraft frames began producing materials for construction and consumer goods, and chemical industries that refined aviation fuel shifted toward plastics and synthetic materials. The same logistical frameworks that delivered engines and ammunition across oceans were repurposed to support global trade networks. What had begun as emergency mobilization evolved into a permanent industrial advantage that outlived the conflict itself. The organizational methods behind this transformation proved equally decisive. The War Production Board coordinated over 184,000 companies, integrating suppliers, manufacturers, and transport systems into a single operational network. Information was processed using early data systems such as IBM punch cards, tracking millions of components across thousands of facilities. This allowed continuous monitoring of production rates, material shortages, and delivery schedules. When bottlenecks appeared, adjustments were made in real time, redistributing resources and modifying production priorities. This level of coordination eliminated delays that would have crippled more rigid systems. German industry, constrained by hierarchical command and fragmented under bombing pressure, could not match this flexibility. Adaptability became a defining characteristic of the system. Combat feedback moved rapidly from frontline units to engineers and then directly into production lines. When bomber formations suffered heavy losses from frontal attacks, design modifications such as chin turrets were implemented within weeks. When range limitations affected operations in the Pacific, aircraft were modified without interrupting existing production schedules. Each improvement was integrated into an ongoing process rather than treated as a separate development cycle. German production, by contrast, struggled to implement changes quickly due to dispersed facilities, material shortages, and bureaucratic delays. Designs remained static while American equipment evolved continuously under combat conditions. The workforce itself represented another critical factor. At peak production, approximately 2 million Americans were employed in the aircraft industry, including large numbers of women, minorities, and previously unskilled laborers. Women alone accounted for over 310,000 workers, performing tasks ranging from assembly to quality inspection with measurable improvements in precision. At Douglas Aircraft, defect rates dropped from 3.2% to 0.3% after female inspectors were introduced. Tools were redesigned to improve efficiency, reducing fatigue and increasing output. This workforce was not coerced but motivated through wages, national purpose, and social mobility. German reliance on forced labor produced the opposite effect: sabotage, reduced efficiency, and declining output. Productivity per worker in Germany fell after 1943, while American productivity increased dramatically. Financial structure reinforced these advantages. War production, costing approximately $45 billion, did not weaken the American economy but strengthened it. Industrial expansion eliminated unemployment, increased wages, and stimulated domestic consumption. War bonds, often purchased by factory workers themselves, funded further production, creating a self-sustaining economic cycle. Germany, in contrast, diverted massive portions of its economy toward war without achieving comparable output, leading to resource depletion and structural imbalance. By 1944, the Reich was consuming industrial capacity faster than it could replace it, while American industry continued to expand. The final stage of understanding came from those who had once dismissed these capabilities. Hermann Göring, during post-war interrogations, admitted that he had underestimated not only American production potential but the ability to execute it at scale. He expressed particular disbelief that a single factory could exceed the output of Germany's entire bomber force. When presented with production statistics, he repeatedly recalculated ratios, attempting to reconcile the numbers with his previous assumptions. The conclusion was unavoidable: Germany had entered a war against an industrial system it did not understand. The broader implication extended beyond the conflict itself. The war demonstrated that industrial organization, not just raw resources, determines the outcome of large-scale conflicts. Systems capable of integrating production, logistics, and continuous adaptation can sustain operations indefinitely, while those dependent on limited resources and rigid structures will eventually collapse. This principle redefined military planning, shifting focus from battlefield tactics to supply chains, manufacturing capacity, and economic resilience. The story that began with a dismissed report in May 1940 ended with a global transformation. A nation once perceived as unprepared became the dominant industrial power, capable of producing more military equipment than all its opponents combined. The shift was not gradual, it was exponential, driven by scale, coordination, and adaptability. The conclusion is precise. Industrial capacity is not a supporting factor in war, it is the decisive one. Nations that can produce, supply, and replace at scale determine not only the outcome of battles, but the fate of entire conflicts. Germany fought with advanced technology and experienced forces, but against an opponent that had transformed production itself into a weapon. That weapon proved unstoppable. October 15, 1946, 21:30 hours. Nuremberg, Germany. Hermann Göring sits in his cell, the walls bare, the war long finished, the verdict already delivered. Outside, guards move through corridors that once held the architects of a regime that believed itself destined to dominate Europe for generations. On the table in front of him lies a final statement, a document not of command but of acknowledgement. 6 years earlier, he had dismissed a report predicting 50,000 American aircraft per year. Now, facing execution, he reviews the numbers that defined the war's outcome: 295,959 aircraft produced by the United States, compared to Germany's 94,677. The ratio is no longer abstract. It is the mathematical record of defeat. He had once believed that technological superiority, centralized control, and disciplined planning would ensure victory. Germany had entered the war with advanced aircraft, experienced pilots, and a production system refined through years of preparation. Early campaigns seemed to confirm this belief. Poland fell in weeks. France collapsed in 42 days. The Luftwaffe dominated European skies. These successes reinforced the assumption that quality and coordination could compensate for limited resources. Yet those victories had been achieved against opponents operating within the same industrial scale. None possessed the capacity to expand production exponentially. The reversal began not with a single defeat, but with a gradual realization that the enemy operated under entirely different conditions. American factories did not slow under pressure, they accelerated. Production systems adapted continuously, integrating new designs, expanding workforce capacity, and increasing output without interruption. Losses in combat were treated not as setbacks but as variables within a larger system. Aircraft destroyed over Germany were replaced within weeks, sometimes days. Entire bomber groups reappeared with identical strength after suffering heavy casualties. This continuity transformed warfare into a process of sustained pressure rather than decisive engagement. German leadership struggled to respond within the constraints of its own system. Efforts to increase production relied on dispersal, forced labor, and intensified control. Instead of increasing efficiency, these measures introduced fragmentation, delays, and declining quality. By 1944, the Reich devoted up to 40% of its industrial capacity to aircraft production, yet still produced less than half of American output. Resource shortages compounded the problem. Fuel limitations restricted pilot training to as little as 60 hours, compared to 250 hours earlier in the war. Replacement crews entered combat underprepared, facing an opponent whose training and equipment remained consistent. Even technological breakthroughs failed to alter the outcome. The Me-262 jet fighter represented a significant advancement, capable of speeds exceeding Allied aircraft by over 100 miles per hour. Yet production reached only 1,430 units, with operational numbers rarely exceeding 200. Engine durability was limited to approximately 10 flight hours, and maintenance requirements further reduced availability. These constraints rendered the aircraft strategically ineffective. At the same time, the United States continued producing thousands of conventional fighters while developing new technologies in parallel. Innovation without production capacity proved insufficient against sustained industrial output. As the war progressed, the imbalance extended beyond equipment into perception. German soldiers and officers began to understand that they were not facing a superior army in the traditional sense, but a superior system. Reports described endless streams of aircraft, uninterrupted bombing campaigns, and supply lines that appeared immune to disruption. The enemy did not conserve resources, it operated with surplus. This abundance translated into operational freedom. American forces could attack continuously, sustain losses, and maintain momentum without pause. German forces, constrained by shortages, were forced into defensive operations, unable to recover once depleted. The final phase of the war confirmed this reality. By early 1945, German production had declined under the combined effects of bombing, resource depletion, and organizational breakdown. Allied forces, supported by continuous industrial output, advanced on multiple fronts simultaneously. The Luftwaffe, once a decisive force, was reduced to limited operations with insufficient aircraft and trained personnel. Ground forces lacked fuel, vehicles, and ammunition to conduct effective counteroffensives. The outcome was no longer uncertain, it was inevitable. Göring's final reflections captured this transformation with clarity he had lacked in 1940. He acknowledged that American industrial capacity had not only exceeded expectations but redefined the scale of warfare. The conflict had not been decided solely by battles or strategies, but by the ability to produce, sustain, and adapt continuously. Germany had prepared for a war of operations. The United States had fought a war of production. This conclusion extends beyond the events of World War II. The conflict demonstrated that in modern warfare, industrial systems determine strategic possibilities. Armies operate within the limits defined by production and logistics. When those limits differ by an order of magnitude, the outcome becomes predictable regardless of tactical performance. Germany's early successes could not compensate for long-term imbalance. The United States' initial unpreparedness was overcome by its capacity to expand and adapt. The lesson is precise and measurable. Wars are not won solely on the battlefield. They are won in factories, supply chains, and systems capable of sustaining operations at scale. Tactical victories can delay defeat, but they cannot reverse structural imbalance. Industrial capacity, once mobilized, becomes a decisive force that shapes every aspect of conflict. Hermann Göring's journey, from dismissing American production as impossible to acknowledging its decisive role, illustrates the cost of misunderstanding this principle. The war was lost not when German forces were defeated in battle, but when they faced an opponent capable of producing more than they could destroy. The difference was not courage or skill. It was scale. And scale, once achieved, proved unstoppable. The story does not end with surrender documents or battlefield maps. Its final layer is numerical, structural, and irreversible. By 1945, the United States had not simply outproduced Germany, it had redefined the scale at which war could be conducted. American industry delivered 295,959 aircraft over the course of the war, including 97,810 bombers and 99,465 fighters, while Germany, despite total mobilization and exploitation of occupied Europe, reached only 94,677 aircraft. This was not a narrow margin. It was a difference so large that it eliminated the possibility of strategic recovery. Even if Germany had achieved local superiority, even if individual battles had been won, the imbalance in production guaranteed that such victories would remain temporary. The implications extended into every operational domain. American forces operated with continuous resupply, maintaining offensive momentum across multiple theaters simultaneously. Aircraft losses were absorbed without altering strategic plans. Bombing campaigns intensified even as casualties mounted, because replacement rates exceeded losses. German forces, by contrast, faced cumulative depletion. Each destroyed aircraft, each lost pilot, each damaged vehicle reduced overall capability. Replacement systems could not match the rate of attrition, and shortages compounded over time. Fuel scarcity limited training, spare part shortages grounded aircraft, and transportation disruptions slowed production. The system did not collapse instantly, it eroded steadily until it could no longer function. What made this imbalance decisive was not only quantity but consistency. American production did not fluctuate significantly under pressure. Factories operated continuously, supply chains remained intact, and output increased even as global operations expanded. This stability allowed long-term planning, enabling sustained offensives such as the strategic bombing campaign and the Normandy invasion. Germany, operating under resource constraints and constant disruption, was forced into reactive decisions. Production priorities shifted frequently, resources were reallocated under pressure, and long-term planning became increasingly difficult. The difference between a stable expanding system and a strained reactive one defined the outcome. By the final months of the war, German command no longer debated victory. The discussion shifted to duration, how long resistance could continue under conditions of material inferiority. Reports emphasized shortages rather than strategy, focusing on fuel allocations, ammunition reserves, and transportation capacity. The language of operations gave way to the language of limitation. Meanwhile, Allied planning extended beyond immediate objectives, preparing for future operations with the assumption of continued supply superiority. The contrast reflected two fundamentally different positions, one system approaching exhaustion, the other operating with surplus. The broader historical conclusion emerges from this disparity. Industrial warfare is governed by production, logistics, and the ability to sustain operations over time. Tactical skill, technological innovation, and leadership influence outcomes at the operational level, but they cannot overcome systemic imbalance. Germany entered the war with advantages in experience, coordination, and early momentum. These factors proved insufficient against an opponent capable of scaling production beyond all previous limits. The United States transformed industrial capacity into a strategic weapon, applying it continuously until opposition became unsustainable. This principle extends beyond the specific context of World War II. Any conflict involving large-scale mechanized forces is constrained by the capacity to produce and replace equipment, supply forces, and maintain operational tempo. When one side achieves overwhelming superiority in these areas, the outcome becomes a matter of time rather than uncertainty. Germany's failure was not a lack of effort or capability, but a miscalculation of scale, an inability to recognize that the war would be decided not by individual victories, but by sustained production over years. The final insight is direct. Wars of the modern era are determined by systems, not moments. Factories, supply networks, and industrial organization define what armies can achieve. Germany fought with advanced technology and disciplined forces, but against an opponent that had transformed production into an unstoppable process. Once that process reached full capacity, the result was no longer in doubt. The war was decided when one side could replace everything, and the other could not. The final layer of this story lies not in destruction, but in transformation. The industrial system that emerged during the war did not disappear in 1945, it expanded, adapted, and redefined global power for decades. Factories that had produced bombers at rates of one aircraft every 63 minutes transitioned to civilian production without losing efficiency. The same assembly lines that built B-24 Liberators began manufacturing automobiles, appliances, and infrastructure components at scales previously unimaginable. Aluminum plants that once supplied aircraft frames now fed housing booms across the United States. Chemical industries that refined aviation fuel shifted toward plastics, fertilizers, and synthetic materials, forming the backbone of post-war consumer economies. The workforce that had been mobilized for war became a permanent industrial force. 2 million workers trained in aircraft production carried their skills into peacetime industries, increasing productivity across sectors. Women who had entered factories in unprecedented numbers, over 310,000 in aviation alone, demonstrated measurable improvements in precision and efficiency, permanently altering labor structures. Techniques developed during wartime, such as statistical quality control, modular assembly, and continuous production cycles, became standard industrial practices worldwide. What had been an emergency system evolved into a new model of manufacturing. Financially, the impact was equally decisive. The $45 billion invested in wartime aircraft production did not collapse after victory, it generated sustained economic expansion. Industrial capacity built for war created jobs, increased wages, and stimulated long-term growth. Infrastructure developed to support military logistics, ports, transport networks, supply systems, became the foundation for global trade dominance. While Germany's economy had been exhausted by total war, the United States emerged with expanded industrial capacity, increased productivity, and a workforce experienced in large-scale manufacturing. The contrast between systems became a lasting historical lesson. Germany's model relied on centralized control, limited resources, and forced labor. It achieved rapid initial results but proved incapable of sustaining long-term expansion under pressure. The American system, decentralized yet coordinated, relied on scale, adaptability, and voluntary participation. It absorbed losses, adjusted continuously, and expanded output even under global operational strain. One system sought efficiency through control. The other achieved dominance through volume and flexibility. This distinction defined not only the outcome of the war, but the structure of the post-war world. Nations that adopted similar industrial principles, mass production, integrated supply chains, and adaptive manufacturing, achieved economic growth and military capability. Those that relied on rigid systems and limited resources faced structural limitations that could not be overcome through strategy alone. The war demonstrated that industrial organization itself is a form of power, capable of shaping global outcomes as decisively as armies or weapons. The conclusion remains precise and unchanged. The conflict was decided not at the moment of surrender, nor at any single battle, but at the point where one side achieved irreversible industrial superiority. From that moment forward, every engagement, every campaign, and every loss followed a predetermined trajectory defined by production capacity. Germany did not lose because it lacked courage, leadership, or technology. It lost because it faced an opponent that could produce faster than it could destroy. And in modern war, that difference decides everything. There is one final detail that completes the picture, one that German leadership only fully understood after everything had already been lost. The war had not just been decided by how much the United States produced, but by how effortlessly it could continue producing without reaching a limit. By 1944, American industry was not operating at maximum capacity, it was still expanding. Aircraft output, already at 96,270 units per year, was supported by a system capable of increasing production further if required. Shipyards launched vessels faster than they could be sunk. Tank factories produced vehicles in cycles measured in minutes. Even losses at sea or in the air failed to create shortages, because reserves already exceeded operational needs. This created a condition Germany had never faced before, an opponent without a visible ceiling. Every German calculation assumed limits, fuel limits, labor limits, material limits, time limits. American production defied those assumptions. The United States was producing 1.8 billion barrels of oil annually, compared to Germany's 33 million including synthetic fuel. That difference alone defined mobility, training, and operational reach. American pilots trained longer, flew more missions, and operated with full fuel loads. German pilots trained less, flew fewer missions, and often entered combat with restrictions imposed by scarcity. The imbalance was built into every aspect of the war. Even more critical was the concept of replacement. In previous wars, losses reduced combat effectiveness on both sides. In this war, only one side experienced permanent loss. When German units lost aircraft, tanks, or trained personnel, their combat power declined irreversibly. When American units suffered the same losses, their combat power remained stable or even increased due to incoming reinforcements. This created a one-directional battlefield dynamic. German strength decreased over time, while American strength accumulated. No tactical success could reverse that trajectory. By 1945, this process had reached its logical conclusion. German industry, fragmented and under constant attack, could no longer sustain even minimal output levels. Transportation networks were disrupted, fuel supplies exhausted, and production facilities destroyed or rendered ineffective. Meanwhile, American production continued at full scale, unaffected by direct attack on its industrial base. The geographic distance between American factories and the battlefield provided an additional layer of security, allowing uninterrupted output regardless of conditions in Europe. The final understanding, recorded in post-war testimonies, was not emotional but analytical. German officers recognized that they had prepared for a different kind of war, one defined by maneuver, concentration of force, and decisive engagements. Instead, they encountered a conflict defined by continuous production, logistical depth, and sustained pressure. The principles of blitzkrieg, effective in short campaigns, proved insufficient in a prolonged industrial conflict where endurance replaced speed as the decisive factor. This realization reframes the entire timeline of the war. The decisive moment was not Stalingrad, not Normandy, not Berlin. It was the point at which American industry reached a scale that Germany could no longer match or counter. From that moment forward, every event followed a predictable pattern. German resistance could delay, but not alter, the outcome. The lesson extends beyond historical analysis. It defines the nature of modern conflict. Victory belongs to the side that can sustain operations indefinitely, absorb losses without degradation, and expand production under pressure. Industrial capacity becomes not just a support system, but the core of military power. Germany entered the war believing that superior tactics and technology would determine victory. It left the war proving that production, logistics, and scale determine everything. And once that imbalance appears, the result is no longer a question of who will win, but only of how long it will take. In retrospect, the most critical failure was not material, but intellectual. German leadership never fully adjusted its understanding of what the war had become. Even as production figures mounted, even as bomber streams darkened the skies over the Reich, decisions continued to be made within an outdated framework, one that prioritized breakthrough weapons, localized offensives, and short-term operational gains. Resources were diverted into projects like the V-2 rocket, consuming vast industrial capacity for weapons that delivered limited strategic impact. At the same time, essential sectors, fuel production, transportation, and standardized manufacturing, remained under constant strain. The system attempted to solve a problem of scale with solutions of innovation, and the mismatch proved fatal. American industry followed the opposite logic. Instead of concentrating on singular technological breakthroughs, it multiplied effective systems. Thousands of reliable aircraft outperformed hundreds of advanced prototypes. Standardization replaced specialization, allowing parts to be interchangeable across production lines and repair units. This reduced downtime, simplified maintenance, and ensured that damaged equipment could be returned to service quickly. A destroyed aircraft was not a loss of design, it was a temporary reduction in numbers, immediately corrected by production. The effect of this approach became most visible in sustained operations. Strategic bombing campaigns continued for months without interruption, delivering thousands of tons of explosives daily. Supply lines fed advancing armies across hundreds of miles, maintaining momentum even as distances increased. Amphibious operations, airborne assaults, and armored breakthroughs were all supported by the same underlying system: continuous production and uninterrupted logistics. Each operation reinforced the next, creating cumulative pressure that no single defensive action could counter. German attempts to respond increasingly revealed systemic limitations. Counteroffensives required fuel that was no longer available in sufficient quantities. New weapons required materials that could not be sourced or transported reliably. Even when units were assembled, they often lacked the logistical support necessary to sustain operations. The result was a series of efforts that achieved temporary success but failed to alter the broader trajectory. Each attempt consumed resources that could not be replaced, accelerating overall decline. By the final months, the contrast reached its clearest form. Allied forces planned operations based on abundance, allocating resources with the expectation of surplus. German forces planned under constraint, calculating every movement based on scarcity. This difference shaped decision-making at every level. One side expanded possibilities, the other reduced them. One system grew stronger over time, the other weakened regardless of action. The ultimate conclusion is not symbolic, but structural. The war demonstrated that industrial capacity defines the limits of military power. Strategy operates within those limits, but cannot exceed them. Germany's leadership recognized this only after the imbalance had become irreversible. The failure was not in execution alone, but in understanding the nature of the conflict itself. The war that began with rapid advances and decisive victories ended as a demonstration of industrial inevitability. Production replaced maneuver as the determining factor. Logistics replaced speed. Scale replaced precision. And once those factors aligned in favor of one side, the outcome ceased to be uncertain. It became inevitable. The final conclusion was not written in speeches or declarations, but in ratios that could not be reversed. By the end of the war, the United States had reached a level of production where even inefficiency no longer mattered. Losses, delays, and operational friction, factors that historically determined success or failure, became irrelevant when output exceeded all requirements. American industry could absorb mistakes, replace destroyed equipment, and continue expanding simultaneously. Germany, operating at the edge of its capacity, could not afford a single disruption without consequence. This asymmetry transformed every aspect of the conflict. What made this decisive was not just scale, but permanence. American production did not peak and decline, it stabilized at a level beyond German reach. Aircraft continued to roll off assembly lines in the tens of thousands, engines were produced in quantities exceeding total German needs, and supply systems operated without interruption. Even as the war approached its final stages, there was no sign of exhaustion. The system had been built not just to win a war, but to sustain dominance indefinitely. German leadership, confronted with this reality too late, attempted to interpret it through familiar frameworks, seeking explanations in technology, tactics, or individual failures. Yet none of these factors accounted for the outcome. The decisive variable was structural. One side had created an industrial system capable of continuous expansion, while the other relied on a finite, increasingly strained capacity. Once these systems collided, the result followed a predictable trajectory. The significance of this extends beyond the events themselves. It marks the point at which warfare became inseparable from industrial organization. Armies no longer fought independently of their economic base, they became direct expressions of it. The strength of a force could be measured not only by its numbers in the field, but by the capacity behind it to sustain, replace, and expand those numbers over time. Germany entered the war believing that victory would be decided by speed, coordination, and superior design. It ended the war proving that these factors are secondary when faced with overwhelming production and logistical depth. The battlefield became a reflection of factories thousands of miles away, where decisions made months earlier determined outcomes in hours. The final insight is absolute. Industrial superiority does not merely influence war, it dictates it. Once one side achieves the ability to produce faster than the other can destroy, the outcome is no longer uncertain. It becomes a matter of time, measured not in battles, but in output. And in that calculation, Germany had already lost before it understood the equation.